4.9 dilations. I can identify and create dilation.
Yes, no?
Yes.
Awesome. What's a transformation, everybody?
A change.
A change. So we know the word transformation, a change, not only in real life but also in math. A dilation is a transformation that changes the size of a shape or of a shape. When you change the size of a shape or when you make a dilation, you're producing a what?
Image.
Image. How are images identified? What are those little markers called? Prime markers. So these prime markers right here are stating that this particular rectangle is the image of the actual or ABCD. And the reason we know it's an actual is because it doesn't have the prime markers, right? Excellent. Sliding down. I'm going to skip center of dilation. Vertex are just vertices where two lines come together, right?
Yeah.
Awesome. Scale factor, that's review, representation over actual. If you shrink an object, the scale factor is going to be what? If you enlarge an object, the scale factor is going to be? And if you just make an exact replica of an object, the scale factor is going to be? 1. So you're going to encounter problems like number 8. Ignore the box around number 8. The question was, what is the scale factor to create the image for rectangle ABCD? We simply found corresponding sides and multiplied? We multiplied? Did we divide?
Yeah.
So because in this situation we are going from this corresponding side to this corresponding side, and we're going from a larger shape to a smaller shape, we're going to use division, right?
Yeah.
And our division is going to be, probably on a calculator, and it's going to be 14 divided by 2 1/10, right? No, why do we know that that answer is wrong? Because 6.666 whatever is bigger than 1, and we're not enlarging, we are shrinking. So just understanding that whole number 1 helps us out. So then we're dividing. I'm sorry, I should do this. We're dividing 2 1/10 and 14, and we found the scale factor is 15/100. And just to double check our work, if we take 10 and multiply it by the scale factor of 15/100, does that get us to 1.5?
Yes.
Obviously it does. Number 9 is just a word problem that you needed to create your own proportion, or if you look beyond, a picture. And then center of dilation, which is the word we skipped above. Quickly, number 10 says, to find center of dilation, you connect corresponding vertices and extend the vertices until they meet at a single point. So our shape here was rectangle ABCD. It's hard to see because of all of our lines. We created an image, A prime, B prime, C prime, D prime, right?
Yes.
We connected A prime and A. We connected B prime and B. We connected C prime and C. We connected D prime and D. And we found a center of dilation that is right here. Yes, no?
Yes.
Ooh, wonderful. B does the exact same thing. We have an actual triangle and then another image, which is right on top of the actual. The center of dilation ended up being point A, because we called this point A on our actual shape, right? Last thing we did is dilating with scale factor. So I gave you, and you guys pretty much figured this out all on your own. I gave you the coordinates for triangle ABC, and you graphed them. Yes, no?
Yes.
And then I told you to dilate that by a scale factor of 2, and that's all. And you all figured out, mostly Tate and Connor over there, but you all figured out that the only thing you can really do is take the given coordinates and multiply them by 2. And when you did that, you got the image, or the vertices, or the vertex, for the image of point A, the image of point B, and the image of point C, right?
Yes.
By multiplying everything by what again?
2.
2. So then we drew our image, A prime, B prime, C prime, and we connected our dots. So we connected A and A, we connected B and B, we connected C and C, and it looked like they came through the origin. But do we know for sure? No. And you guys figured out then that if I find the slope from A prime to A, which was, I think, what, -4, -2? Oh, it says right here, I guess. And then if I followed that exact same slope, I ended up at the origin. And if I found the slope from, and this is getting really messy, from B prime to B, and then followed that slope one more time, it ended up at the origin, and so on and so forth. So therefore, now I mathematically prove that the center of dilation was the origin. And another word for origin, or another way to describe the origin is what? Questions?